Hello, and welcome to our lesson on rotations in geometry. In this lesson, we'll be focusing on the concept of rotations and how to perform and describe them using tracing paper. Here's an outline of what we'll cover. We'll start by understanding what a rotation is and how it differs from other transformations like translations and reflections. Next, we will learn how to perform rotations using tracing paper, which provides a hands-on approach to visualizing and understanding rotations. Finally, we'll summarize the specific rotation results for common angles to reinforce your understanding. Let's start with the definition of rotation. A rotation in geometry is a transformation that turns a figure around a fixed point known as the center of rotation. There are three key concepts to remember here. First, the center of rotation, which is the fixed point around which the figure rotates. Second, the angle of rotation measures the degree to which the figure is rotated. Third, the direction of rotation tells us whether the shape has been rotated clockwise or anti-clockwise. Now we know what rotation is, let's turn to how we can perform rotations with tracing paper. We will look at this through an example. Suppose we have been asked to rotate the point A by 90 degrees anti-clockwise around the origin. The procedure for performing rotations using tracing paper is as follows. For step 1, place a sheet of tracing paper over the coordinate plane. Trace the point or figure you want to rotate. For step 2, identify the center of rotation. Often the origin, 0, 0, is used, but rotations can also occur around other points. Mark the center of rotation on the tracing paper. Step 3 is to determine the angle and direction of the rotation. For our example, we need to rotate point A by 90 degrees anti-clockwise. Step 4 is to rotate the tracing paper according to this information. Place a pin or pencil point on the center of rotation to hold the tracing paper in place. Then rotate the tracing paper by the specified angle and direction. We can see that A has now moved to the coordinates -3, 2. Finally, after rotating the tracing paper, carefully transfer the new coordinates of the figure back onto the original coordinate plane. Use this to draw the new shape. Let's try a few more examples. First, rotate point B around the origin by 180 degrees. Pause this video and try this out. First, trace point B and the coordinate axes on the tracing paper. Place your pencil at the origin and rotate the tracing paper by 180 degrees. The new coordinates of point B will be 1, -4. Notice that it doesn't matter whether we rotate clockwise or anti-clockwise here because the angle of rotation is 180 degrees, so we get the same result both ways. Next, let's rotate point C around the origin by 90 degrees clockwise. Notice that this is the same as rotating it 270 degrees anti-clockwise. Start by tracing point C and the coordinate axes on the tracing paper. Place the pencil at the origin and rotate the tracing paper 90 degrees clockwise. The new coordinates of point C will be 1, -4. We can also use a similar technique to identify rotations. When given a figure and its rotated image, you can determine the center, angle, and direction of rotation by comparing the coordinates of corresponding points. For example, suppose we have been given the coordinates of an original triangle ABC and the points of the triangle following its rotation. If we are also told that the center of rotation is the origin, describe the rotation. Start by using tracing paper to draw a sketch of the triangle ABC. Then place your pencil at the origin, which is the center of rotation, and see how many degrees you need to rotate the triangle ABC to get it to perfectly overlay the rotated triangle. We find that it is a 90-degree anti-clockwise rotation. We can confirm this by comparing coordinates. Based on these examples, we can note some specific rotation results. First, a 90-degree anti-clockwise rotation, which is the same as a 270-degree clockwise rotation, means xy becomes -yx. Second, a 180-degree rotation, which is the same regardless of whether it is clockwise or anti-clockwise, means xy becomes -x minus y. Finally, a 270-degree anti-clockwise rotation, which is the same as a 90-degree clockwise rotation, means xy becomes y minus x. Why is this important? Well, rotations are commonly used in fields such as computer graphics, for instance rotating a character in a video game to face a different direction. Rotation is also used in engineering in the design and analysis of mechanical systems and structures, such as rotating parts in machinery. Rotations are also used in navigation systems, for instance, adjusting a ship's course using rotational navigation techniques. In today's lesson, we explored the concept of rotations in geometry, focusing on how to perform and describe rotations using tracing paper. We started by defining a rotation as a transformation that turns a figure around a fixed point called the center of rotation. We discussed how a rotation is characterized by three key elements: the center of rotation, the angle of rotation, and the direction of rotation, clockwise or anti-clockwise. We then moved on to performing rotations using tracing paper, demonstrating a hands-on method to visualize and understand rotations. By using specific examples, we practiced rotating points and shapes around the origin, enhancing our comprehension of how coordinates change under different rotations. Finally, we summarized the specific results for common rotation angles to reinforce the patterns in coordinate changes. By mastering these techniques, you can confidently manipulate figures on the coordinate plane and solve complex geometric problems involving rotations.